My name is Greta Thakran from Basic Chemistry Honors from Basic Chemistry second year. Today I made a video on the chapters alcohol and phenols. Let's start. You have learned that the separation of one or more hydrogen atom from a hydrocarbon by another atom or a group of atoms results in the formation of entirely new compounds having although different properties and applications. Alcohol and phenols are formed when a hydrogen atom in a hydrocarbons aliphatic and aromatic respectively. It is replaced by the OH group. These classes of compounds find wide application in industry as well as in the day-to-day life. For instance, have you ever noticed that the ordinary spit used for polishing wooden furniture is chiefly a compound containing hydroxyl group ethanol? The sugar as wheat, the cotton used for fabrics, the paper we use writing are also made up of the compounds containing OH group. Just to think of life without paper, no notebooks, books, newspapers, currency notes, checks, etc. The magazines carrying beautifully disappears from our life. It have been really a different world. An alcohol contains seven more hydroxyl directly attached to the carbon atoms of an aliphatic system CH3COH, while a phenol contains OH groups directly attached to the carbon atom of an aromatic system C6H5OH. The separation of the hydrogen atom in a hydrocarbons by an alkoxy or alkoxy group yield another group of compounds using as ethers. For example, CH3COH, CH3. You have me visualize ethers as compound formed by substituting the hydrogen atom of a hydroxyl group of an alcohol and phenols by the alkyl or allyl group. In this unit, we have discussed the chemistry of the three classes of in alcohol phenols and ethers. The classification of compounds make their studies systematic and simple. Therefore, let us start. Alcohol and phenol may be classified as mono, tri, and polyhydric compounds depending on whether they contains one or two or more hydroxyl groups respectively in the structures. Monohydric C2H5OH is the monohydric CH2OH, or which CH2OH is dihydric, and which are in three compounds. There is a trihydric. Monohydric compound may be classified compound containing sp3OH bond in the classes of alcohols. So H is attached to the sp3 hybridized carbon atom of an alkyl group. They are further classified as follows: primary, secondary, and tertiary alcohols. The type of alcohol OH group is attached to the primary, secondary, and tertiary atoms respectively as depicted below. Primary alcohols in which one OH group is attached to the CH2, and secondary in which OH group attached to the CH, and the tertiary OH group attached to the C carbon. Allylic alcohols in these alcohols, the OH group is attached to the sp3 hybridized carbon atom attached to the carbon-carbon double bond. It is allylic carbons. For examples, primary, secondary, and tertiary. Benzylic alcohols in the alcohols OH group attached to the sp3 hybridized carbon atom next to the aromatic ring. For examples, these are the primary and secondary and tertiary. You have to see on the screen. Allylic and benzylic alcohols can be in primary, secondary, and tertiary compound containing sp2OH bond. The alcohols contains OH but bonded to carbon-carbon double bond to a vinylic carbon or allylic carbon. These alcohols are also known as the vicinal alcohols. These are the monohydric, dihydric or trihydric examples. Nomenclature of alcohols. The common name of the alcohol is derived from the common name of the alkyl group adding to the word alcohol to it. For example, CH3OH is the methyl alcohol. According to the IUPAC system, the name of the alcohols is derived from the name of the alkane from which is alcohol is derived by substituting E of alkane with the suffix OL. The position of the substitution are indicated by the numericals. For example, the longest carbon chain parent chain is number starting at the end nearest to the hydroxide group. The position of the OH group and the other substitution is indicated by using the number of carbon atoms to which these are attached. The one naming polyhydric alcohols, the E of the alkane is retained and the ending OL is added. The number of OH group is indicated is the adding of a multiplicative prefix ditri etc. before OL. The position of the OH are indicated by the appreciate locations. Example OH CH2 H is named as ethene 1,2-diol. I have to say in the IPS in nomenclatures. CH3OH is the common name is methyl alcohol and IPS is the methanol. CH2OH is N-propyl alcohol or what pitch name is propane 1-ol. You have to see these different examples. Then we found the cyclic alcohols are named with the prefix cyclo and considered as OH group as C1. These are the cyclohexanol and the second is the 2-methyl cyclopentanol. Phenols. The simplest hydroxy derivative of benzene is phenol. It is a common name and also as a accepted IUPAC name as structure of phenol involves a benzene in the associated carbon atom. The terms ortho 1 to disubstitute, meta 1 3 disubstitute and para 1 4 disubstitute are often used as the common names. You have to change the examples. The first is the phenol, second is the cerol, orthocerol, second third is the metacerol and fourth is the paracerol, in which OH group are attached to the ortho, meta and para position with CH3 group. Hydroxy derivatives of benzene are 1 2 1 3 and 1 4 benzene diol. There is the catechol, second is the racethinol and third is the hydroquinone or quinonyl. Ethers. Common names of the ethers are derived from the alkyls. Periodic order of the in the end of the is ethyl methyl ether. You have to see some examples of the ethers. First of all, we structure of the functional groups. In alcohols, the oxygen of the OH group attached to the carbon by the sigma bond formed by the overlap of the sp3 hybridized orbitals. Carbon of the sp3 hybridized orbitals of the oxygen receptor structure accept of the methanol, phenol and methoxymethane. The methanol, phenol and methoxymethane. The bond angles in alcohols is slightly less than the tetrahedral angle 109 to 28 degree. It is due to the repulsion between the unshared electrons pair of the oxygen in phenols. The OH group attached to the sp2 hybridized carbonate of the aromatic ring. The carbon oxygen bond length is 136 picometer. In phenols is slightly less than the in phenol. This is due to the one partial double bond character on account of the conjugation of the unshared electron pair of the oxygen with the aromatic rings. The second is sp2 hybridized state of the carbon to the oxygen is attached. In ethers, the four electron pairs, the two bonds pair, and two lone pair of the electron or oxygen are arranged proportionally in the tetrahedral arrangement. The bond angle is slightly greater than the tetrahedral angle due to the repulsion interaction between the two bulk groups. The CO bond length is 141 picometer, is almost the same as the alcohols. Then is the preparation of the alcohols. From first is one from alkenes. By acid catalyzed hydration, alkenes react with the water in the presence of the acid and catalyzed to form the. In case of the unsymmetric alkenes, the addition reaction takes place in the according to the Marconi's rules, in which C double bond C plus में H2 after reaction then it form the CH और एक C के साथ OH ऐड जुड़ जाएगा. इसमें इसका mechanism, the mechanism of the reaction involves the following three steps. First is the step is protonation of the alcohols to form the carbocation by electrophilic attack of CO H3O positive. H2O plus में H positive, then it form the H3O positive. Then carbon carbon double bond अटैक, इसमें कार्बन अटैक करेगा एच पे और उसके इलेक्ट्रॉन्स एच के इलेक्ट्रॉन्स को ले जाएगा ओ. देन इसमें सेकेंड के आफ्टर फॉर्मेशन दैन इट फॉर्म द सी कार्बोकेटायंस प्लस में H2 बाहर निकल जाएगा. सेकेंड में न्यूक्लियोफाइल अटैक ऑफ द वाटर ऑन कार्बोकेटायंस. इसमें वाटर के इलेक्ट्रॉन्स कार्बन के पॉजिटिव चार्ज पे अटैक करेंगे और जिससे OH वहाँ पे आकर जुड़ जाएगा. थर्ड वन इज द डिपोर्टेशन ऑफ द टू फॉर्म एन एल्कोहल्स. इसमें H3O पॉजिटिव बाहर निकल जाएगा और उसमें और OH वहाँ पे जाके जुड़ जाएगा. Then is the by the hydroboration oxidation diborane CH3 twice react with the alkanes to give a trialkane or addition product. This is exhausted by alcohol hydrogen peroxide in presence of the aqueous sodium hydroxide. And CH3CH double bond CH2 plus में H BH2 और इसका twice 2 is then form the CH3CH CH3CH2 CH2 BH2. In this में ऐड करेंगे CH3CH और डबल बॉन्ड CH2 then it form the CH3CH2 CH2 का twice BH. इसमें फिर से हम एल्केन्स को ऐड करेंगे in and form the propane 1-ol. Addition of the boron of the double bond take place in a substituent manner that the boron atom get attached to the sp2 carbon and carrying greater number of the hydrogen atom. The alcohol also formed. The look at has been formed by the addition of the alcohol water to alkane in wave positive. The Marconi rule in the reaction alcohol is obtained in excellent yield. Second is from the carbonyl compound. The addition of the alcohol and aldehyde and ketones are reduced by the corresponding alcohols by addition of the hydrogen. The presence of catalyst hydrogen. The usual catalyst is finely divided metals such as platinum, palladium, or nickels. It is also prepared by treating aldehyde and ketones with sodium boron hydroxide NaBH4 or lithium aluminium hydroxide aldehyde yields primary alcohols whereas ketone gives secondary alcohols. Second, by the reduction of the carboxylic acid or esters, carboxylic acid are reduced by the primary alcohols in excellent yield by the lithium aluminium hydroxide, a strong reducing agent. However, LiLH4 is expensive reagent and is therefore used to preparing special chemicals only. Commercially, acid is used to alcohol by converting them to the esters. Reaction using hydrogen in the presence of catalyst catalytic hydrogenation. We formed the first of all we'll take the carboxylic acid, then in which will form the esters, then after the catalyst H2 then form the alcohols. From Grignard reagent, alcohols are prepared by the reaction of the Grignard reagents with aldehyde and ketones. The first step of the reaction is the nucleophile addition of the Grignard reagent to the carbonyl groups to form the adduct, and hydrolysis of it adduct yields as an alcohol. The reaction using different aldehyde and ketone are follows. SCHO plus में RMGX and form the RCH2O MGX. इसमें वाटर की reagent डालेंगे and form the RCH2OH plus में MgOH निकल जाएगा साइड प्रोडक्ट्स के रूप में. सेकेंड इज RCHO plus में R dot MgX then form the RCH R dash is OMGX. इसमें वाटर डालेंगे तो इसमें सेकेंडरी अल्कोहल मिल जाएगा. देन देयर इज टर्शियरी अल्कोहल भी इससे मिल जाएगा हमें. We will notice that the reaction produces primary alcohol with methanol and secondary alcohol with other aldehyde and tertiary alcohol with ketones. Preparation of phenols. Phenols can be also be carboxylic acid was first isolated in the early 19th century from coal tar. Now this phenol is commercially produced. Synthetic is laboratory phenols are prepared from the derivatives in the following methods. From haloarenes, carboxyl is fed with the NaOH plus at 623 Kelvin and 330 atmosphere pressure. Phenol is chlorobenzene is fused with the NaOH at 623 and 320 atmosphere and formed of sodium hydroxide. From second is the from benzene sulfonic acid. Benzene is sulfonated with oleum and benzene sulfonic acid is formed and converted sodium phenoxide on heating with molten sodium hydroxide. Reaction of the sodium saltius phenols. On in benzene we the volume the SO3H and it form the alcohols. From diazonium salt and aluminum salt is formed by the reacting aromatic amines with nitrous acid at 273 to 278 kelvins at diazonium salt and hydrolyzed phenol by warming the water or by treating at the dilute acids. From cumin, phenol is manufactured from the hydrocarbon cumin is oxidized in the presence of the air in cumin hydroperoxide. It is converted to phenol and acetone by heating it. You dilute acid. Acetone is a product by the product of the reaction is also called as the last point is this method. Physical properties alcohol and phenols consist of the two parts an alkyl group of the phenyl group. Properties of alcohol and phenols are chiefly the hydroxyl group. The nature of the alkyl and aryl group simply by these properties. Boiling point. The boiling point of alcohol and phenols increase in the number of the carbon atom in alcohols. The boiling point increase with increase in branching carbon chain. And van der Waals forces decrease with the surface area. The OH group is involved in entomolecular hydrogen bonding. It is interesting in order the boiling point of alcohol phenols are higher in the comparison to the other classes of compounds, namely hydrocarbons, ethers, alkones, aerosolines, and comparable molecular mass. For example, ethanol and propane have comparable molecular mass, but their boiling point deeply differ widely. The boiling point of the methoxy is intermediate to the boiling points. The high boiling point of the alcohol is mainly due to the presence of the intermolecular hydrogen bonding in the term of which is leaking ethanol and hydrocarbon. Solubility. The solubility of the alcohol and phenol is due to the water ability to form the hydrogen bond with the water molecules as shown. The solubility increases with the increase in the size of aryl and several of the lower molecular mass. Alcohols are miscible with water in their properties. Chemical properties. Alcohols are blister compounds. They react to both as nucleophiles and electrophiles. The bond between the OH is broken when alcohols react with the nucleophiles. The second is the bond between the CO bond is broken when the electrophile proton alcohols react as in the manners. Based on the cleavage of the OH and the COH, the reactions and coefficients will be divided into two parts. First is the reactions involves cleavage of the OH bond. Acidity of alcohol and phenols. First is the reaction with the metals, alcohols and phenols react with the active metals such as sodium, potassium, aluminum to yield corresponding alkoxide peroxide hydrogens. In these examples, addition of the alcohol react with aqueous sodium hydroxide to form the sodium phenoxide. The above reactions show the alcohol and phenol are acidic in nature. In fact, alcohol and phenols are Bronsted acids. They have donated a proton as a strong base. And acidity of the alcohol, the acidic character of the alcohol is due to the polar nature of the OH bond. Electron releasing group increase electron density on oxygen, tending to the decrease the polarity of the OH bond. The decrease is the acidic strand of the reason. The acid strand of the alcohol decrease in the following order: then primary, secondary, and tertiary. However, weaker acid than water, this can be restricted in the reaction of the Lexide. This reaction shows the water is the better proton donor, stronger acid and than alcohol. In the above reaction, we know that the alkoxide ion is the better proton acceptor than the hydroxide, which is the instant alkoxide, or stronger base. Sodium is a stronger base than the sodium hydroxide. Alcohol acts as a bronzed basis as well as due to the presence of the unshaded electron pair on them, which makes them proton acceptors. Acidity of the phenols, the reaction of the phenols of metals, sodium, aluminium, sodium hydroxide indicate the acidic nature. The hydroxyl group in phenol is directly attached to the sp2 hybridized carbon atom of the benzene, which acts as an electron withdrawing group. Due to this, the charge distribution in the phenol molecules is dissipate in the resonance structure. This causes the oxygen of the positive. The action of phenol with excess sodium hydroxide indicates the phenol has stronger base acid alcohols and water like compound in the carboxyl group attached to the aromatic ring in the acidic then one of the which hydroxyl group attached to the alkyl group. Alcohol and phenols take place as follows. Due to the higher reactivity recipe to hybridized carbon in the phenol attached to the OH group is attached, electron density decreases on oxygen. This increases the polarity of the OH bond and results in an increase in ionization of the phenols. Then the alcohols net examine the stability of the alkoxide and phenoxide ions and alkoxide, and the negative charge is localized on oxygen, while in the phenoxide the charge is delocalized. Delocation of a negative charge makes phenols more stable and favors the ionization of phenols. Although there is a loss of charge decollocation in phenols, its resonance structure have charge separation and due to the phenol molecule is in this phenoxide. Let us now the esterification. Alcohol and phenols react with the carboxylic acid, acid chloride, and acid anhydride to form the esters. These reactions are Reaction with alcohol, carboxylic acid and acid is carried on the presence of the small amount of concentrated sulfuric acid. The reaction is irreversible and therefore there is water is moved in sun's form. The reaction is carried out in presence of the base or the neutralized HCl with the foam during the reactions. It shifts the equilibrium to the right hand side. The introduction of the acetyl group is alcohol. Phenol is also an acetylation. Acetylation of salicylate is aspirin. Second is the reaction involving case of carbon oxygen bond in the alcohol. The reaction involves cleavage of CO bond takes place only in the alcohol and phenol in the reaction zinc. Reaction of the hydrogen halide. Alcohols react with the hydrogen halide to form the alkyl halides. The difference in the reactivity of the three classes of the alcohol and phenols are distinguished from the one another is Lucas test. Alcohol soluble in Lucas reagent concentrated HCl and ZnCl2, while their halides are miscible and produce turbidity in the solution. In case of tertiary alcohol, turbidity is produced immediately as they are formed halides easily. Primary alcohols do not produce turbidity at room temperature. Reaction with phosphorus trihalide and alcohols are converted to the alkyl bromide by the reaction with phosphorus tribromide. Dehydration is the dehydration alcohol undergo dehydration to form the alkenes on treating with the protic acid. Consider H2SO for H3PO3 for its catalyze the anhydrous zinc chloride or ammonium. It undergoes dehydration by heating it with concentrating H2SO4 at 443 Kelvin. Second, in Russia, are dehydrated under milder conditions. This reactive is the dehydration of alcohol follows the tertiary, secondary, and then primary. The mechanism of the dehydration of ethanol follows from first step is the formation of the protonated alcohols. Second step is the formation of the carbocation. It is slow step and hence the rate remaining the step. And third is the formation of ethane by elimination of a proton. Fourth is the oxidation. Oxidation of the alcohols involves the formation of the carbon oxygen double bond with the cleavage of an OH and a CH bond. Which bond breaking such a cleavage, the formation of the bond occurs in the oxidation reaction. These are the all known as dehydrogenation reaction, as this involves loss of the hydrogen from an alcohol molecule depending on the oxidizing agent used. Primary alcohol is oxidized to form the aldehyde, which is turned off the oxide to the carboxylic acid. Strong oxidizing agent acidified potassium permanganate are used as getting carboxylic acid as alcohols directly. CrO3 anhydrous medium is used as the oxidizing agent in the isolation of the aldehydes. A better agent for oxidation of primary alcohols aldehyde good yield in the pyridinium chromate compared to the chlorine is pyridine with HCl. Second alcohol oxidized to ketone by chromic anhydride. Tertiary alcohol do not undergo oxidation reaction under the addition acts as strong oxidizing agent and the elevated temperature. Cleavage of the various C bond take place in the mixture of the carboxylic acid containing lesser numbers of the carbon atom is formed. When the vapors of a primary or secondary alcohol are passed over the heated carbon at 473 Kelvin, dehydration will take place and the aldehyde ketone is formed as tertiary alcohols under dehydrogenation. Reactions of phenols. First is the in electrophilic aromatic substitution in phenol. The reaction will take place in the another aromatic ring are electrophilic substitution reactions. The OH reactor the benzene activates it towards electrophilic substitution and so it directs to the incoming group of the ortho and para position in the ring forms electron rich to the resonance effect caused by the OH group. The structures are followed by the acidity of phenols. Common electrophilic substitution are the nitration with dilute nitric acid at low temperature at 298 Kelvin. Phenol is a mixture of the ortho and para nitrophenols. The ortho and para isomers can be separated by the stream distillation. The ortho nitrophenol is stream volatile due to the intermolecular hydrogen bonding, while para is less volatile due to the intermolecular hydrogen bonding, which causes the association of the molecules. When concentrated nitric acid phenol is converted to the 2,4,6 nitrophenol, the product is commonly used as picric acid. The yield of the reaction is poor. The acid is prepared by the treating phenol first with the concentrated sulfuric acid and converted into the phenol to form sulfuric acid, and then we concentrate nitric acid to get the 2,4,6 nanometer phenols. Second is the halogenation on heating in phenols with the bromines. Different reactions are formed with under experimental condition when a reaction is carried out in the solvent of the lower polarity such as CH3Cl or CS2 and low temperatures monobromide phenols are formed. The usual hydrogenation of phenols benzene takes place in the presence of the Lewis acid such as the FeBr2 vaporize the halogen molecules. In case of phenol, the pollution the bromine molecules take place even in the absence of the Lewis acid due to the highly activating effect of the OH group attached to the benzene. Me is the phenol is treated with the bromine water to first type phenols. It's formed as the white precipitates. Second is the Colbert reactions. Phenoxide ion is degenerated. Ion generated by the treating phenol with the sodium hydroxide is even more reactive than the phenol towards electrophilic aromatic substitution. Hence, it is undergo electrophilic substitution with the carbon dioxide. A weak electrophile ortho hydrobenzoic acid is formed as the main reaction product. Second thought is the aromatic reaction on heating. Treating phenol with the chloroform in the presence of the sodium hydroxide CHO is introduced on the position of the benzene. This reaction is the aromatic reaction. The intermediate substitution is benzyl chloride is hydrolyzed by the presence of the alkali to form the salicylic acid. Salicylic aldehyde. For the reaction of phenol with zinc dust, phenol is converted to benzene on the heating with the zinc dust. This is oxidation. Oxidation of phenols with the chromic acid produces a conjugated diketone known as benzoquinone. In the presence of the air, phenols are slowly oxidized by the dark color mixture containing quinones. Thank you.